Okay, today we're going to learn about normal distributions, and I'll review the empirical rule with you guys. You learned that last year, and then we'll start to figure out whether a distribution is approximately normal, and that's one of the things you're going to have to do for your project that's due next week. So according to the CDC, the heights of 12-year-old males are approximately normally distributed with a mean of 149 and a standard deviation of 9. Sketch this distribution labeling the mean and 1, 2, and 3 standard deviations above and below the mean. So I'm just going to draw in the horizontal axis, put on my curve, and it doesn't have to be perfect. Make it look as much like you can as a bell shape. And then the center will be the mean, and that is 149. And then I'm going to go 1, 2, and 3 standard deviations above, and 1, 2, and 3 standard deviations below. And then to get to the next standard deviation or the next location, I'm just going to add 9, the standard deviation. So I'll have 158 here, and then I'll add again, and I get 167, and then I add again, I get 176. So 176 is 3 standard deviations above the mean. Then I'll do the same thing on the left side. So I'll subtract 9 and get 140. Subtract 9 again, I get 131, and again, and I get 122. So that is what the sketch of this distribution would look like. And then we're going to be able to use the empirical rule in just a minute to figure out the likelihood for someone to be between 140 and 149, for example. Okay, moving on to Kobe Bryant. We have a little example here. And the question is, can you determine the percentage of the games that fall within 1 standard deviation of his mean, and then also within 2 standard deviations. So I need to compute those intervals. So first I'll start with the mean at 26.8, and I'll add and subtract 1 standard deviation, which is 8.6. And that's going to give me an interval from I looked at the wrong thing. That's going to give me an interval between 18.2 and 35.4. So 18.2 and 35.4. And I'm just going to write it in interval notation. And to find out the number of observations or the percentage of observations that fall between those two values, I'm going to go to the graph here and I'm going to mark them. So this goes by 2, so 12, 14, 16, 18, and since it's 18.2, I want anything to the right of this, and then 35.4, so go 32, 34, 36, so anything to the left of 36 is going to work for me. Now, what I'm going to do is count the observations in this interval. So pause the video and go ahead and count those intervals and see or observations and see what you get. Okay, so you should have gotten 57 observations in this interval. So for 1 standard deviation within the mean is going to be 57 over the 82 games, and that is going to give me approximately 0.695. So in percent form, it'd be 69.5%. Then I need to find the interval that I'm looking for 2 standard deviations. So I'll do the work over here for this one. 26.8 plus 2 standard deviations of 8.6, and that is going to give me 9.6, 44. Now I don't need to count all these in the middle again, I already have them. So what I want to do is frame the next interval and count the extra observations. So 9.6, since this is 8 and 9 is here, it's going to be everything to the right of this all the way up to 44, which is right here. So here I get 12 observations here and 11 observations here. And when I add all those together, I get 80 observations out of 82, which is going to be 0.976 or 97.6%. So you remember the empirical rule is 68, 95, 99.7. And the way that it works is your percentage of your distribution within 1 standard deviation should be roughly 68, within 2 should be roughly 95, within 3 should be roughly 99.7. So what I'm seeing here is pretty close to 68 within 1 standard deviation, and it's a little bit bigger than it should be here, but it's still not too terribly off from the 95% within 2 standard deviations. So I want you to try the next example on your own, so pause the video and then we'll check back in and make sure you understood it. Okay, so here we have a mean of 8.2 and a standard deviation of 2.8. So within 1 standard deviation, I will do the 8.2 plus and minus 1 standard deviation, which is 2.8, which gives me an interval of 5.4, 11. So I'm going to go mark that on my graph over here. Now this is a scale by 1/2. So it goes 2, 2.5, 3, 3.5, 4, that kind of thing. So when I get to 5, which is right here, I want anything to the right of that because this would be 5.5. So really, I'd really put it right there at 5.4. Then go to 11, which is right here, and I want to include those observations. It's rare that it'll fall on the line, but it actually does here. And you're going to count all of these observations, and when I count those, I get 23 observations. So it's 23 out of 32, because they told us there were 32 games, and that is going to give us 0.719. Or 71.9%. So again, not terribly far from what we might expect at 68%. Then for the 2 standard deviations, I'll do that work over here. I'm going to have 8.2 plus and minus 2 times 2.8. And that is going to give me an interval of 2.6, 13.8. So I need to go mark these. So 2.6, so this is 2, and this is 3, so 2.6 would be somewhere right around there. So I'm going to pick up 4 extra observations here. And then when I mark the 13.8, this is 13, this is 13.5, so it's really right about there. So I add on 3 more observations. So I'm just going to add 7 observations. That's going to give me 30 out of 32, which is going to be roughly 0.938. So it's a little bit less than the 95% you might expect. So it'd be 93.8%. Okay, so hopefully you understand how you can determine if a distribution is approximately normal. And in this case, I would need to see some more evidence, but it's not terribly off from what you might expect. So far I don't have any reason to doubt that it's somewhat normal. So moving on. Now, we talked about the 68, 95, 99.7 rule. Basically, this is just what it means within 1 standard deviation, within 2 standard deviations, and then within 3 standard deviations. And does it always apply? No, it does not. It's only when your distribution is approximately normal. And then, do you need to know Chebyshev's inequality? And the answer is no. It's not an AP Stat standard. Alrighty, moving on. Now, I want to show you how to set up a distribution or a generic way of looking at the distribution so you can always use it to figure out the probabilities. Okay, again, not the most beautiful curve there, but right in the center is my mean, and then I'll go 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. And each of these is going to have like their own little interval, like their own little percentage. So I'll draw these as straight as I can. Same thing over here. Whoops, I messed that one up. And now, how is the breakdown going to work? Well, if we have symmetry for a normal curve, and in the middle within 1 standard deviation is 68%, so all I'm going to do is divide 68 by 2, and I get 34% in both of these intervals. Then I have to take the 95 and subtract 68 because that gives me how much extra should be in these two, and these are the same percentage in each of these. So when I subtract that, I get 27, and then 27 divided by 2 is 13.5%. Then I take the 99.7, and I get 4.7, divide that by 2, and I get 2.35%, 2.35%. And then finally, these little tails will always be 0.15%, sorry, 0.15%. It looks like a decimal, but it is a percentage. So using the earlier example about what percentage of 12-year-old boys will be over 158 centimeters. So I need to remember where that is. So I have 149, and then that means I have 158 right here. So it's all three of these right intervals. So it's going to be 13.5% plus 2.35% plus 0.15%, and I believe that adds up to 16%. And what percentage of 12-year-old boys will be between 131 and 140? We have to carry this over to the left, so 140, 131. This is just going to be 13.5%. So you just have to look at the intervals and add them up. All right, suppose that a distribution of test scores is approximately normal and the middle 95% of scores are between 72 and 84. That means that when I set up my little formula, I'm using 2 standard deviations above and below the mean. And I know that's giving me an interval that is 72 to 84. So I really need to know the midpoint here. I don't know if you guys remember how to find the midpoint, and this is just like you would do it algebraically. So you would just do 84 plus 72, and the order does not matter. And then when you do that, you're going to get 84 plus 72 divided by 2, and you're going to get 78. So 78 is your mean here. And it's because we're assuming that it's an approximately normal distribution. And that means that the mean will be in the center, just like the median would be in the center, roughly. So then I can set up a little equation. If I know 78 is the mean, add and subtract 2 standard deviations, and that gives me the value of 84. And I could solve it either way. I could subtract 2 or add 2. So then I would subtract 78 from both sides. So then I get 2 standard deviations is going to be 84, and then just divide that by 2, so you're going to get 3. Your standard deviation is 3. So divide by 2, and divide by 2. So standard deviation is 3. So just kind of checking yourself out, if you had a mean of 78 plus and minus 2 standard deviations of 3, that would definitely give you 78 plus 6, which is going to be 84, and then 78 minus 6, which is going to be 72. So that's how you would find that. Can you calculate the percent of scores that are above 80? So again, we need to draw on our curve and figure out where 80 falls in our curve. So here's our horizontal axis and the curve. And if the center is at 78, and we're going up by 3 each time, so then we get 81, then we get 84, and then what do we notice? We notice 80 falls right here. It's not falling on one of our nice, neat little intervals that match the empirical rule. So we can't do anything with this today, but I will give you a heads up. We will be computing or finding out the z-score for 80, and we're going to figure out how to find the probability that an observation falls above that. All right, do homework number 3 tonight, and we will take a look at that tomorrow.